Here we determine the cross-sectional area of the beam, which is to be cut from a cylindrical log of diameter d equals 24 centimeter. So here we have the different pictures of the log or the beam which is to be cut from the cylindrical log. So this is one way which we can do. This is the beam is basically representing the rectangle. So I can label this beam as ABCD, which is exactly the same as ABCD. However, its shape is little bit different when compared with the first and the second way of cutting the beam. Now basically we have to represent the area in terms of theta. As we know that rectangle has four corners of right triangles. So we can represent this as right triangles like this. In fact, we can consider only this figure because this is almost symmetrical to this figure. We just have to express the area in terms of the depth and width. Finally, it will be in terms of theta. So let's write the area as a function of theta. So if we focus on this picture, we have a right triangle ABD. ABD is a right triangle. In this right triangle, I can write down a trigonometric ratio, that is sine of theta. This is equal to opposite side by adjacent side. The opposite side by hypotenuse. Opposite side is AD and hypotenuse is DB, which we can write down as opposite side AD is basically representing the depth, and divided by dB. dB is the diameter of the log, which is d. I can replace this as a d, or otherwise I can replace this as 24. So from this I can solve for depth if I multiply both sides by 24. So just have to focus these two parts. So basically depth gives 24 sine theta. And similarly, in the same triangle, I can find another trigonometric ratio, that is cos of theta. This is equal to adjacent side, which is AB, over hypotenuse, which is once again dB. So when I substitute for AB, which is basically the width of the beam, divided by the diameter of the log, which is 24 centimeter. So when you relate these two terms, we can solve for width equals 24 cos theta. Now the area of the beam is basically area of the rectangle. So therefore area is equal to depth times width. We substitute the values of depth and width. So this comes out to be 24 sine theta multiplied with width is 24 cos theta. So when you multiply the numbers, we get 24 times 24 is 576. This is 576 sine theta cos theta. And this we can represent as A of theta. This is the area function which is based on theta. So as theta changes, the area will also change. The area of the beam will also change. So this is the area of the beam in terms of theta.